Hi everyone, thank you for watching this video. Now in this part of the lesson today we'll be looking at straight line graphs, mainly focusing on the types of question for at the Sec 1 level. So in this part of the lesson we'll be revising on the following. Number one, the general equation of a straight line, and we know that the general equation of a straight line is y equals to mx plus c, where m tells us the gradient of the straight line and c is the y-intercept. Okay, then after that we also have some questions where we find out how do we find the x-intercept and y-intercept given the equation of a straight line. We can also use the equation of straight line to find certain information. For example, if I'm given the x value, how do I calculate the y value? Or if I'm given the y value, how do I calculate the x value? And also we'll be drawing a straight line where you need to plot a table usually, and then there will be some key points. The minimum number of points to draw a straight line is two points, two set of data x and y, but it's usually good to have one more extra point to check the accuracy of your line. So usually we'll construct a table of at least 3 sets of values. Okay, and last but not least, we'll be looking at application of a straight line graph in a practical situation. Right, without further ado, let's begin. Question 1. The line 2y equals to 4x cuts the y-axis at the point A and x-axis at the point B. Now, what does this actually means? When you say cut the y-axis, it means x is equals to 0. Correct? So when we want to cut the y-axis, we want to find the y-intercept. So x is equals to 0. We sub x equals 0 into the equation. And next one, when it says you cut the x-axis, that means y value is equals to 0. And we'll sub in y equals 0 to find the x-intercept. Okay, next part of question, part A says, find the gradient of the line AB. So the gradient of the line, usually we will use the gradient formula, y equals to a gradient equals to y2 minus y1 over x2 minus x1. But in this case, there's no points given. So what we are going to do, we are going to use the general equation form. The general equation of a straight line is y equals to mx plus c, where m is the gradient and c is the y-intercept. Okay, so now what do we have? We have the equation to be the form 2y equals to 4x plus 7. But our normal form should supposed to be y equals to mx plus c. This is 2y over here. So what can we do? We are going to make y the subject. We're going to have only y. We don't have 2y. So we shall divide throughout by 2. So divide it being individually by 2. 4 divided by 2 will be 2x. 7 divided by 2 will be 7 over 2. Then you match this with y equals to mx plus c. M is the number in front of the x term. So the number of units of x. So the gradient m is equals to the number 2. So in this case, gradient of the line AB will be equals to 2. Okay, next part of the question. Find the coordinates of A and B. Well, what's the coordinates of A? Coordinate A cuts the y-axis. So to find coordinates of A, it cuts the y-axis, meaning x is equals to 0. Okay, so our equation, we have 2y equals to 4x plus 7. So that will be 2y equals to 4 times the x plus 7. X is now the number 0. So 2y is equals to 7. Y is equals to 7 over 2. Actually, if you were to observe very closely, this is the same as the y-intercept. Okay, so the coordinates where it cuts the y-axis, that is actually the y-intercept. Now the next part of question says they want coordinates. So this answer have to be in a coordinate form with brackets, comma, x and y value. So the x value will be the number 0. Okay, and y value is the number 7 over 2. Next one, we want to find the coordinates for point B. Point B cuts the line cuts the point B at the x-axis. So when it cuts the x-axis, y is equals to 0. So we're going to sub this into our equation. 2y, which is now 0, equals to 4x plus 7. So we have 0 equals to 4x plus 7. We'll bring the 7 over to the other side. We'll get negative 7 is equals to 4x. I do not want 4. I'm going to divide by 4. So therefore, x is equals to negative 7 over 4. Okay, and again, they want coordinates. So B is the point, x is the number, negative 7 over 4, and y is the value 0 over here. Okay, have you gotten the answer? Next part of the question. Okay, find the area of the region bounded by the line AB, x-axis and y-axis. So what is the region bounded by these three lines? Okay, that means it's the region trapped by these three lines. So first I will have the line AB, and then the x-axis, and then the y-axis. So in this case, the region trapped by these three lines is actually over here. Okay, but to find this is the shape of a triangle, right? Area of triangle is given by half times base times height. But there's no number because this one is a 90 degree, but there's no number. Is it really true that there's no number? What have we found just now? We found A is the point 072. So x is 0, y is the number 7 over 2. B is the point, x is negative 7 over 4, then 0. This x is negative 7 over 4. Then y is 0. So if this is the case, what does it tell you? It means this whole length over here has the value 7 over 2 units. And this length over here, this is length, the coordinates is negative 7 over 4, but the length means it's 7 over 4 units. So now I want to find the area of this triangle, this region bounded, will be half times base times the height. So half times 7 over 4 times 7 over 2. So area of the region bounded will be half times the units 7 over 4 times the height 7 over 2. Square units. So let's work out this number. And I get the answer 49 over 16. Or if you think it's not, if you think you prefer a fraction, you can write fraction, or you can write it as a mixed number, units, square units. Okay. So do not just count the squares if it's given a graph. Okay, you count the number of units. Next question. This person here, Mary, says that the point 2350 lies on the line AB. Is Mary correct? Give a reason for your answer. What does this mean? Okay, let's take a look at our equation. We have the equation 2y equals to 4x plus 7. I need to verify whether is it true. Okay, so what you can do now is, I know that here x is equals to 23 and y is equals to the value of 50. So what I need to do is, I'm going to try to sub in one of the value and test whether will, for example, I substitute inside x and I test whether is y really equals to 50. Okay, now sometimes some students like to sub in both the answers, then you get to know where, because you know all the numbers already. So what we can do is we just sub in one of the answer. So when x equals to 23, you just sub in this part first, and you're going to find y. Okay, so 2y is equals to 4 times 23 plus 7. 2y is equals to plus 7, 99. Then y is equals to 99 divided by 2, which gives me 49.5. But however, this does not equals to the value 50. Okay, so since this is the case, this is the reason for your answer. Since when x equals to 23, y is equals to 49.5, okay, does not equals to 50. Therefore, is Mary correct? No, Mary is not correct. Because this point 23, 50 does not lie on the line. Okay, it does not satisfy the equation. However, if you plug in one value, x equals to 23, and you work it out and that y is really 50, or that the numbers tallies, then that answer you say that Mary is correct because the point lies on the line itself. Okay, so in this part of the question, we have covered how to identify the gradient and the y-intercept using the general equation from of a straight line. How do you find the x-intercept, y-intercept, and the coordinates? Okay, how do you find the region of area of triangle? Okay, and how do you verify whether does the point lies on this set of line or not? Okay, we're going to move on to the next part of the question where we need to do a little bit of drawing. Question number 2, the diagram shows 3 points. P is the point 2, 6. Just let me make it smaller. Q is the point 2, 4, 2, 4. And R is the point 6, 2. Okay, on the axis above, plot the point 4, 6. So x coordinate is 4, y coordinate is 6. So this will be the point 4, 6. Okay, next part of the question. Write down the name of this quadrilateral PQRS. Now you notice something, just to highlight, when you have no comma sign in between all this means P has a particular sequence. P goes to Q, goes to R, and then go to S. So there's a particular sequence where you need to draw the whole thing. P go to Q, Q go to R, and R goes to S. So let me try to complete this drawing. Okay, so we have our drawing over here, PQRS. So what is this shape? This is actually the shape of a kite. Now there are several different types. Okay, for example, you can have a trapezium, or you can have a parallelogram. Okay, or you can even have a rhombus where the diagonals bisect each other at 90 degrees and all the sides, 4 sides are equal. Okay, or you can have triangle, isosceles triangle, equilateral triangle, many different things. Okay, but depends. The common ones are usually parallelogram and probably trapezium. Okay, next one. Write down the equation of PQ. Oh, notice this word, it says write down. That means the equation is going to be easily found. You don't need to do too many steps to find the equation of a line PQ. So we know that in general there are 3 different types of lines, 3 different types of straight lines rather. Okay, the first type is the type that is a vertical line. Okay, a vertical line cuts the x-axis at a particular number, let's say A. So in this case, when there is a vertical line, it cuts the x-axis. This line will be x equals to a number. Okay, the second type, you have a line, a horizontal line, Okay, a horizontal line cuts the y-axis at maybe a particular number. So if it only cuts the y-axis, then the equation will have only letter y. So it will be y equals to A, for example. But when we have a slanted line, for example like this, or the other way round, let's say going up, it cuts both the x and the y axis. It cuts both the x and the y-axis. So in this kind of question, when you have a slanted line, it will be in the equation of the form y equals to mx plus c. Okay, you notice if it only cuts the x-axis, right? If it only cuts the x-axis, it will be x equals to. If it only cuts the y-axis, it will be y equals to. If it cuts both the axes, you will have y and x. Cut both the axes, you got y and x. Okay, so let's take a look at our question. What axis does it cut? Okay, so now question over here, write down equation of line PQ. So where is the line PQ? The line PQ is a vertical straight line. If I were to extend this line, it cuts the x-axis at the number 2. So it's a vertical straight line, it only cuts the x-axis. So in this case, this equation will be just x equals to 2. Have you gotten the answer? Okay, next one. Let's find the area of triangle PQR. Now, previously, the other question, we have the area of the triangle, half times base times height. That's very easy because we have a 90-degree angle. But I remember our triangle PQR here is slanted. Okay, let's take a look. We have this triangle over here, PQR. Let me highlight this. PQ and R. So this is actually not an upright triangle. So if I want to find the area of triangle, I need to take area of base times perpendicular height. Which base can I use and where is the height? Well, I can use this to be my base. Okay, and remember, don't just count the squares, read the number of units. This is from 4 units to 6 units. So down here is actually 2 units on my base. Okay, and where will be the perpendicular height? The perpendicular height will be from R, go perpendicularly until you reach the base, okay, but extended. So in this case, you have a 90 degrees here, but my perpendicular height has how many units? It will be 1, 2, 3, 4. Well, don't just count the squares. Read the number of units, because sometimes one square can represent 5 units. Then the length will be different. Okay, so in this case, this is from 2 all the way to 6. So from 2 to 6, it's by 4 units. Although coincidentally, it's 4 square, but we cannot always assume that's the case. So area of triangle is half times the base and the perpendicular height, which is 4. So half times 2 times 4. Okay, so we have our area of triangle. And that will give me 4 square units. Okay, let's move on to the next question. Question says find the gradient of the line QR. How do I find the gradient of the line QR? Let's recall a little bit of our formula. The gradient formula is given by, if I have 2 coordinates, or if I have the equation, but in this case, I do not have the equation, I only have the coordinates, right? So the coordinates of Q is given by the point 2, 4, and the coordinates for R is given by the point 6, 2. Correct? So now gradient is given by the formula y2 minus y1 over x2 minus x1. Okay, so y2 and y1, so let's label this. This is x1, y1, for example, x2, y2. Of course, we can label it the other way. Q is x2, y2, then R is x1, y1. Doesn't matter. Okay, so according to our formula, gradient is y2 minus y1. So that will be y2, 2 minus y1 is 4, over x2 is 6, minus x1 is 2. Please be careful with the position. Do not anyhow switch the numbers. Okay, so I'll get my answer to be, okay, give me a minute, negative half. Okay, so the gradient will be negative half. Negative indicating this is a downward sloping line. Okay, so no problem. Next question. The line PR has this equation y plus 8x equals to 8. A point 4.25a lies on the line PR. When it says lies on the line PR, it means it must satisfy this equation. So when I have this point, 4.25a, what does that mean? The 4.25 is the value for the x coordinate, and the a is the value for the y coordinate. So I want to find the value of a. I'm going to substitute when x is equals to 4.25 and y is equals to the value for a. You notice my presentation have changed. I'm not looking for y, I'm looking for a. So it's a plus 4.25 is equals to 8. So a will be equals to 8 minus 4.25. Okay, and that answer will be 3.75. Have you gotten the answer? Okay, if you gotten the answer, then we're going to do the last question. Okay, we'll need to do a little bit of drawing, so get your rulers and pencils ready. Question number 3. Now, question number 3 here, we're going to look at applications of straight line graphs on a practical real-world situation. Okay, for example, question 3 over here, an open tank, okay, is filled to the brim, okay, and water is drained off. So the water keeps going out such that the height of water at any time t seconds is given by this formula for the timing between 0 to 30. Now you notice our normal straight line equation is y equals to mx plus c. But where is the y and where is the x? There's no y and there's no x. In this case, it's just given by h and t. Alright, so it means certain things. Okay, and let's take a look at some of the corresponding value. The t is the time in seconds. Okay, and h is the time, the units in cm, the height in cm. Calculate the value of m. When it's m, t is equals to 15, h is equals to m. So when t equals to 15, h is equals to m. So the height h is now m is equals to negative 2, 15 minus 30. You plug in and let's work out the answers. I got the value to be 30. Okay, so in this case, the value for n will be just the number 30. Right? Next part of the question, it says using a scale of 2 cm to represent 5 seconds. For me, because when I took a screenshot of this whole thing, the scale changes a little bit, and in my video I'm not able to measure for you using my ruler the actual cm, but we do know on a normal graph paper, alright, 10 small squares represent 2 cm. Okay, 5 small squares represent 1 cm. So if they want to have a scale of 2 cm to represent 5 seconds on a horizontal t-axis for 0 to 30. So what do I need? I need to start from 0 to 30. 2 cm to represent 5 units. So this will be 5, 10, 15, 20, 25, 30. Okay, so we're supposed to use a pencil to draw your answer, but I should just write in my blue color so that you're able to see. So this is my 5 units, 10, 15, 20, 25, and 30. Now this is my t-axis, which is in seconds. Right, you notice this one replaces your x value, right? And next one, we're going to draw our h, the height itself. Now our smallest value is 10, the largest value is 50, and they tell me to draw a vertical axis from 0 to 60, 2 cm to represent 10 cm, the height 10 cm. So 2 cm will be 10 squares, Oh, this is a little bit difficult to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cm, 20, 30, I hope I get it correct, 40, 50, and 60. Now in the new trend, for examinations, they will print black and white copy of the graph paper for you, and it's a little bit difficult to see everything in black and white compared to our normal green color graph paper. So you have to be extra careful when you draw your graph, okay? So do count the units or squares if you are not very sure. Now let's plot in our graph. When t is 5, h is 50, so we'll mark with a cross. Then 10, 40 is here. 15, 30 is here. Then 20, 20 is here. And last but not least, 25 is 10. This will be down here. Okay, so we have a series of our points, and we shall draw our line, draw the graph of all this thing. Now, this case, right, you notice the graph have a range of from 0 to 30. So technically speaking, I'll draw the graph from 0 to 30, and I'll just extend the whole line within 0 to 30, the whole region. Okay, let me just try to draw a straight line graph passing through this. Okay, hopefully it's correct. Okay, so this is my straight line graph, right? So when we have a straight line graph already, we must remember to label our equation. So h equals to negative 2t minus 30. Okay, so this is my equation. Now let's use this graph to find some of the different answers. Okay, next part of our question. Okay, give me a minute. Okay, for this part of the graph down here, we have question C. It says, using your graph, state the height of the water in the tank when t is equals to 0. So in this case, it tells me that t is equals to 0. So when time t is 0, actually when it comes to time, right, there's one word that you actually need to know. This one is called the initial. Okay, initial starting time, the initial height, or initial something. When it's at the initial means when the time haven't even started. So that is when time is t equals to 0. So they want you to state the height of the water in the tank. It means I'm looking for my initial height. Or when time is equals to 0, the height of the graph over here, this is the value 60. So the height of the graph, remember height has a unit. So in this case, the height is equals to 60 cm. Okay, so what is the physical meaning of the value that you have stated? It means that the initial height of the water, so the water was filled to the brim, right? The open tank is filled to the brim. Okay, the initial amount, the initial height of the whole tank is 60, or rather the whole height of the tank, because it says that the open tank is filled to the brim, the height of the tank is actually 60. So there are two different types of answer that you can use. The initial height of water in the tank is 60 cm. Or you can also say that because it says that the open tank is filled to the brim, that means the height of the tank is 60 cm. Okay, but in this case, I think they will probably prefer the height of the tank is 60 cm. Okay, next part of the question. from your graph, the question says from your graph, that means they don't want you to do the calculations and you have to show the working by putting in the dotted lines to show that you are reading it from the graph. Find the height of the water at 23 seconds. What is 23 seconds? This means t is equals to 23. So when t equals to 23, find the height of the water. So find the value for h. So the height of water is how many cm? Okay, so let's take a look at our question over here. We have t equals to 23. So I have 10 squares over here. Okay, so 10 squares represent 5 units. 1 square will represent 0.5 of a unit. So 1, 2, this will be 21, 22, and 23. So when we are at 23, we need to put our dotted lines up to our graph. And then we read across. Okay, you can show the dotted lines that we are doing the readings right down here. Then let's take a look at our axis over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 squares to represent 10 units, 10 to 20. Then 1 square will represent 1 unit. So this number will be 1, 2, 3, 4, 14. Okay, so please do the dotted lines and the estimation from your graph. Try to draw it as close, as accurate as possible. If not, your answer will not be correct. So this will be 14 cm. They want the height, so there's a unit to it. Okay, next one, find the time taken, meaning what is the time when the height to reach 35. So height is given to be 35. We're going to find the t, the time is how much. So when height equals to 35, let's take a look at where is 35. 35 is over here. Then we're going to put our pair of dotted lines. Draw it in pencil, please. Here, 35 over here. And we'll read the time axis. This number here will be in the middle of 10 and 15. So this number will be 12.5. Okay, so we will have t equals to 12.5 seconds. Okay, next one, after n seconds, the graph becomes invalid. What do you mean by after n seconds? When will it become invalid? That means probably when the water is totally drained off, right? How long did it take to drain off until everything is gone? Okay, what do you notice? If I were to extend my line, there's this portion of my graph that actually goes below the axis. This one, can height be equals to a negative value? So this portion over here, this portion is invalid. Why? Because height cannot be negative value, is not applicable. And what is the time period, after which time period? The mark point where it becomes, the height becomes 0, this timing is actually at 30. So after 30 seconds, anything after 30, or is the graph will be invalid. So what's the value for n? N will be equals to 30. So state the value of n, 30. Explain why the graph is invalid after 10 seconds. Because after 30 seconds, okay, height will become negative, h becomes negative, which is not correct lah. It's not it's invalid. Okay, have you gotten the answer? With that, we have come to the end of today's lesson. We'll see you for the next lesson. Bye.